The builder pattern allows us to construct complex types in simple steps. For example, in our previous video, which you don't have to have watched, we had a user struct that had a username, an email, and a date of birth. In that video, we allowed the date of birth to be set later, but a user also had to be older than 21, which I said at the time was silly to check after the user was created. If we were to make all these fields required, creating the struct gets a bit unwieldy. Do we instantiate it manually or write a constructor? If we manually instantiate it, we can't validate the fields. If we write a single constructor, the parameter names are slightly obfuscated, but worse than that, we have to cram all our validation into a single function. This isn't so bad in our example user struct, but what if you're working with a more complicated structure with numerous fields, many of which require validation? This is where the builder pattern comes in. Instead of constructing the object directly, we use another type to manage the construction. The builder type collects data about the struct we want to create and then has a finalizer that creates the struct from the data we've given it. There are arguably two versions of this pattern. A simpler version that will work in just about any language that I'm going to refer to as the builder Lite, and a more complex version that only works in languages with strict generic typing, the TypeState Builder. Each has their own pros and cons, so let's go over them. The traditional builder pattern uses a type that mirrors the type you want to build, but everything is optional. We use methods to update each field and have a finalizer that takes the data we've stored in the builder and attempts to convert it to the target type. Let's build one for our user example. Before we start on the builder though, we need to set up an error type as there are lots of ways this could go wrong. The user builder itself looks just like the user, except the fields are all optional. Each of our withers will set the relevant value and return a new version of the user builder with the new value. Am I trying to make withers a thing? Yes. Will I succeed? Probably not. Our first potential error is when setting the date of birth, where we test if the user is at least 21. This doesn't matter to our Fluent interface in Rust so long as you're using the builder in a context where you can bubble the error. Our finalizer method is called build and simply checks to see if all the optional parameters have been set. If we missed any values, we'll return an appropriate error, or if everything is okay, we'll return a built user. Here's an example of where the user will be built successfully. And here's an example where we'll get an error. The biggest pro of this pattern is it's really easy to understand at a glance and pretty easy to maintain. The biggest con though is that we should know at compile time that that second usage was never going to succeed. Let's use the type state pattern to make that problem go away. If you're not already familiar with this pattern, we do have a video on it, but the TLDW is that you can bake the state of something into its type. We can then decide what you're allowed to do with the data by restricting behavior with its type state. Let's make a type state builder for our user. First, we can edit our error down to a single event now. The others won't be possible when we're done. Next, we're going to use a generic type for each of the properties in our builder. These generics can either be the type they're supposed to be, or something that represents the fact that we haven't set them yet. To achieve this, I've created an unset unit struct and a trait to restrict each generic. This may not be necessary, but it is tidy. We'll implement each trait for unset as well as the type we actually want it to become in user. Now we can create our builder and the properties are all generics restricted by the relevant traits. So U can be username or unset, E can be email address or unset, and D can be date of birth or unset. Next, we're going to implement user builder 3 times, each with different generic variants. The first one we'll implement is where all of our generics are unset. This allows us to have a constructor for the builder that returns a version where everything starts off unset. Next, we want to implement the user builder where we don't know what the generic types are. Each method here consumes the builder and returns a new builder with the data we wanted set. This updates the type, setting the generic we care about to that particular type, but keeping the others as whatever they were when the method was called. For example, the with username method will return a user builder with the first generic parameter set to username, but the other two will just be whatever they were when that method was called. Same for the with email method. The with date of birth method is a touch different because it returns a result. The OK variant will still inherit whatever concrete types U and E were previously set to. Finally, we'll implement user builder where all our generics are now the types we want them to be. Here's where we put our finalizer method. Because this method is only implemented for the concrete version of user builder where all our generics match the types in our user struct, we can just copy them straight over. When we come to use this pattern, we need to provide all the necessary data or the user cannot be built. The build method simply doesn't exist unless we've done that, so this code won't compile, specifically telling us that build does not exist for user builder, username, unset. This is objectively awesome. There are two big pros to this pattern. The obvious one is that we cannot mock up building our user type, but it's also worth pointing out that we've removed all but one branch in our code, which will provide a significant runtime benefit. The downside though is this code is just more complex to look at, particularly for newer engineers where all those triangle brackets might be intimidating. Should you just use the more complex but safer and faster TypeState Builder? That probably depends on your team and your project requirements, but my advice is to trust yourself and your team. It might require talking through a couple of times, especially if you're building something particularly complex with your builder, but getting out of our comfort zones helps us develop our skills. If you enjoyed this video, don't forget to like and subscribe, and if you really like the video, you can become a member of the channel or join the Patreon. See the description for more. Next time, we're going to talk about higher order functions and do our best to demystify the fact that Rust has numerous closure types. So join me next time for that.